So what you're going to do is you're going to open GeoGebra. It's not the 3D GeoGebra, it's the classic, right? Classic or, well, basically anything that's not geometry or 3D, right? So once you do that, it's pretty much just typing straight away. There's nothing too elaborate about it. So let me just zoom in here. Oh, I already forgot. We've gone through this before. Yeah, but then I gotta. I hate this. Right. I just don't like that coming up. Like, I want that to go away. Like, well, yeah, that's the answer, obviously. So you're just typing in the curve with the control points, right? So there's a little blurb on the history behind Bezier curves and why it's cool and why we learn about it, but this is really just more procedural than anything else, right? So what I'm going to do is just type in curve. It calls for an expression, all right? So just making sure. This is the part where if you're going to get jammed up, this is where it's going to happen. So it doesn't look like you need to put an operation or I got caught in between operation and operator. An operator between 4 and 1 minus t cubed. But generally speaking, with numerical values, it's all right. But once you start getting into variables, it can be a little wonky. So just as a habit, if you have a coefficient in front of a binomial, trinomial, any kind of expression or a quantity within parentheses, what you're going to do is type the coefficient times, then type in your 1 minus t, then get outside of the parentheses. Now, the little shortcut key, I mean, it's not required because you can use the keypad that's here. But if you hit Alt, so what does Alt stand for? Alternate? Alternate? Right, if you hit Alt and any number, it makes that number a power. All right, so if I want a power of 3, I just hit Alt 3, and it'll make it a power. And then, more importantly for me, return the cursor to the normal size. All right, so that's not a necessary skill, but it's a helpful one, I think. So then plus 84 times t times the 1 minus t squared. All right, plus 150 times, all right, so it's already getting annoying, right? T squared times, you can hear times in your sleep now, times plus 40t cubed, you should be able to type it in straight away, but I'm not going to take a chance, times t cubed. All right, that's my first equation, comma, 1 minus, oh, I got to go back in here. Get over here. 1 minus p cubed, so Alt 3, plus 144 times t times 1 minus t squared plus 126 times t squared times, again, on and on. Keep hitting that multiplication. If you don't, it may not matter, but when it does matter, you're going to hit enter and nothing's going to happen and you're going to be staring at it and you're not going to understand why. All right. So then I did 5 times 3 t cubed comma, t, comma, 0, comma, 1. All right. An equation appeared below after I typed that in, so I'm pretty satisfied that I didn't just screw that up royally. If I screwed it up, I screwed it up in a very minor way. I can live with minor. Royally is the problem. All right, so what we have here, and I can zoom out, is the Bezier curve that I'm looking for. All right. So, and let me just bring this, and actually let me get this back to 100% because I was messing around with that. So then you get into the other aspects of it with segment, all that stuff. That's going to work out fine. You're not going to have trouble with that. You type in your coordinates, you type in the segments. That's not going to be a problem. The next part of it that can be a little funky is the part with the sliders. Making what? Well, that's after the sliders. Okay, well you should do it after it.
Is that the noticeable letter of the alphabet?
Yeah, we'll go with that. So we need to create sliders using the same expression, but that can be pretty easy depending on how you go about doing things. All right, so just going back to this, what I would do is duplicate. Well, I'm not going to do, let me get rid of that. Eventually we'll duplicate it, but we want to get our sliders in first. All right, now A was already used, and if you want to use A as a slider, that would be problematic. So what I can do is I can change the name of this particular curve to something else. Just go in here and make it a capital A. All right, so that lowercase a is freed up to be used as a slider. So when I type in A, I get a slider. Type in B, C, D, E. Well, E is E, so can't use E. F. Sometimes if you have a problem with F, it could be because F is already defined as a function. So if that's the case, it actually, if you get an error for any of them, it's probably because the variable is already used. All right, so G, and how many do I need? I need 4 for each. 1, 2, 3, 4. Yeah, so I need a total of 8. 1, 2, 3, 4, 5, 6. I need 2 more. So H, I didn't hit create slider. I is usually something else, yeah, like the imaginary unit. J is available, so I'll use that. All right, so after I do that, then I'm going to duplicate my original curve. And really, I mean, it really is just a matter of replacing your coefficients with the values you use as your sliders. All right, so you can, I mean, there's more to it than that, but this gets the job done, and that's all we really need. So A multiplied, don't forget to make it multiplication. All right, so B times T. I'm going to throw in a multiplication again after the T, just in case GeoGebra forgot that I put it in there the first time. Then C. I'm going to put the multiplication in again, like I'm saying, just in case GeoGebra forgot. D times T squared. So we're good there. Then we need a coefficient for this. We're up to F times G times H times and J times. All right. And hit enter. And you have, it looks like a little smidge of nothing here. All right, so I'm gonna turn this one off because I don't want to see it. But this, you're like, oh well, I failed. I didn't do what I needed to do. Right? But if you start moving this around, you can see that it's changing its orientation. Now, they're on different scales, so you'd have to bring it into C1, and that's perfectly fine. And zoom out to see the other one. So now I could start playing around with it and see what I need to come up with in order to create, for example, something that is a reasonable approximation of the letter C. All right. So that's really all there is to it. But if you've tried this and didn't meet with success immediately, it was probably because of the multiplication component. That's generally when people go wrong on this, that's generally where they go wrong. All right. So let me upload this for you.